Hello and welcome to 5.2. All right, so yesterday you worked on linear systems. You had two equations, two unknowns, and you saw those. Today we're going to do three equations and three unknowns. This is actual like 3D stuff is what it really is. There's an X, Y, and Z axis. It's quite cool. But we are not going to graph them. We're just going to solve them. So here we go. We're going to verify a solution of a system just like we did with the linear equations, and now you're going to plug them in and find if three, like your point, x, y, and z, are actually solutions of all three of these lines. You're going to solve the system of linear equations in three variables. So this is actually 3D. And then you're going to use this, solve problems with 3D. All right, so here we go. So first, I just want to know if -1, -4, and 5 is a solution. And it's just like we did last time. We plug the -1 in for x, the -4 in for y, and the 5 in for z. So we plug those in here. We get 22 equals 22. First one checks. But you must do all three. So again, we're going to plug in the -1 for x. We're going to plug in the -4 for y. And we're going to plug in the 5 for z. Does that equal 5? So we've got -2 plus 12 minus 5. -7 plus 12 is absolutely 5. That checks. Next one, plug it in here. So we have 3 times -1 minus 4 minus 5 times 5. Does that equal -32? So it's -3 minus 4 minus 20. 5. Can't even multiply. Does that equal -32? And the answer is check. Yes, it is a solution. All right, your turn. So pause and try yours. You have 2, 1, and 0 to plug in. So the first one, you should have plugged 2 in for x. So you would have had 3 times 2 plus 1 minus 0, because that's 0. Does that equal 7? The answer is check. Next one, -2 times 2 plus 4 times 1 plus 0. Does that equal 0? -4 plus 4 is 0. Check. Next one, 2 minus 3 times 1 plus 0. Does that equal -1? And the answer is check. Yes, it is the solution. All three lines intersect at this point. This is actually an x, y, z axis. It looks like this. This is x, and it goes straight out here for y, and then it goes up here for z. And this is actually a line that goes through all three of those. It's kind of fun. Maybe we'll get to graph them later on. Okay, next we're going to do elimination. It's called triple elimination. So you pick two of the equations, you eliminate a variable. Whatever variable you choose, you must eliminate from the third equation. Okay, you create two equations and you eliminate a different variable. So this is like we did yesterday. And then you solve for a variable and you substitute it back in. So let's go. It really doesn't matter what we pick here. So I'm going to start with the first two. And I look at the x's. I have a 1 and a 3, a 4 and a 2, and a -1 and a 1. Well, the z's are already set up for us. So I'm going to eliminate z from these first two equations. So you take x plus 4y minus z equals 20. And then 3x plus 2y plus z equals 8. And you just have to add them up this time because they're already opposite. So we have 4x plus 6y equals 28. Hey, I know that can be reduced by 2, but first I want to check to see if I actually want to do that. So let's see what our next equation is. So now I have to use this one, and I can either use one of these two. It doesn't matter. You get to choose. So when I look at these, I like the -z. So I'm going to pick the first one and the last one, but it has to be this one because I haven't used him yet. I have to eliminate z because I eliminated z the first time. And I want an equation with x and y in it so I can eliminate those. So now, in order to eliminate z, I got to multiply the first one through by 2. So when I look here, that's going to be 2x plus 8y minus 2z equals 40. I distributed the 2 through to everybody, including my answer. My other one doesn't need anything, so I'm just going to write him down. Minus 3y plus 2z equals -16, and then we add, because I have opposite coefficients here. and we get 4x plus 5y, these cancel, equals, what is that, 24? All right, now I've got my two equations. Now I have to combine these two equations and eliminate another variable. So I'm looking at my x's and my y's, and my x's are both 4, so I need to multiply one of these by a negative. So it doesn't matter, I'm just going to pick this one. All right, so the 4x plus 5y equals 24 stays the same. I'm not changing this one. Okay, I'm going to multiply through by a negative 4 and write him down. So minus 4x minus 6y equals a negative 28. All right, I have opposite coefficients, so we're combining these two and we're eliminating again. The x's go away. I have a negative y equals a negative 4 divided by a negative 1, so y equals 4. I have found my first variable. Now I just use substitution, backwards into my equation. So I go to one of my equations that has an x and a y, and it doesn't matter which one. So I'm just going to pick, let's say, this guy. All right, I'm going to take the y and I'm going to plug it in there and solve for x. Oh, if this would stop doing that, that would be very helpful. Okay, let's try it again. Hopefully it doesn't jump this time. Okay, so I'm going to take this y and I'm going to plug it in right here and we're going to solve for x. So now we have 4x plus 5, that's an x, times 4 equals 24. So 4x plus 20 equals 24. Subtract the 20 from both sides. You get 4x equals 4. So x equals 1. Okay, you have the x and the y. Now you have to solve for z. So we go back up to one of my originals. One of these three here. Does not matter which one, so I'm going to pick this one. The x plus 4y. I should use a different color. Let's do blue. So we're going to take this one. X plus 4y minus z equals 20. And we're going to plug in our x and our y. So let's see, let's go down here. So we're going to take the x, which is the 1, plus the 4 times the y, which is 4, minus z equals 20. And now we're just going to solve that for z. So we have 1 plus 16 minus z equals 20. So 17 minus z equals 20. So z equals 3, negative z equals 3. So z equals negative 3. So our point now is 1, 4, negative 3. And that's our answer. Okay, now it's your turn. I want you to pause and actually try this. Take your time, be careful. It does not matter which variable you choose to eliminate, as long as you choose it twice. Okay, I hope you did a good job. I chose to eliminate z. I picked the first two equations right here, and I got rid of z by multiplying this one here through by a 2. So I multiplied by 2, and I got this equation. Then I chose the bottom two this time, so these two. I multiplied the top one by a positive 3 and the bottom one by a negative 2. Remember, one positive, one negative, so I get opposite signs. And when I did that one, I got these two equations, and this is my resultant one. Now I took my two equations I had here. I eliminated y, so I multiplied this guy by a 4. So I took my first one and I left him alone, multiplied by 4, added those together, got x equals negative 1. I plugged negative 1 into my equation up here, and I got y equals 2. And then I plugged those into the top equation, and I got z equals negative 3. You could have done yours completely different, but your solution set should have been the same, negative 1 to negative 3. Okay, next is if I give you 3 points, I want you to create the equation of a parabola. So I know that y equals ax squared plus bx plus c. So y and x are my points. So I have 1, 4, 2, 1, and 3, 4. All I'm going to do is plug the x and the y's into this equation and create my formulas here. So first I got 4, because that's y, right here, equals 1 squared, so a plus 1 times b plus c. That's my first equation. So my second equation is now I'm going to use my second point, right? And I'm plugging it straight into here again, though. So y is 1. Now I got to square the x this time. So that's 4a plus just an xb, so that's 2b plus c. So this here is my second equation. Then my third equation, we're plugging in 3, 4. So now 4 is my y, equals square the 3, so 9a plus the 3b plus the c. So these are my 3 equations, and I need to eliminate. If you notice, the c is the same in all, so I'm going to choose c to get rid of. So I'm going to take the first 2, and I'm going to take these 2 right here, this one and this one. I'm going to eliminate c. I'm going to multiply this guy through by a -1. So I'm going to have a -4 equals minus a minus b minus c. I'm going to add that to 1 equals 4a plus 2b plus c. Add those together, and I've got -3 equals 3a plus b. Okay, that's putting these 2 equations together. Next, I'm going to use the top equation again because a, b, and c are pretty simple, right? Take him with my bottom one, again multiplying through by a -1. I'm kind of out of room here. So we're going to take the -4, the -a minus b minus c, and we're going to add it to the 4 equals 9a plus 3b plus c. C's cancel again, and I have 0, which that is fine. There's nothing wrong with that. 8a plus 2b. All right, now I'm looking at my 2 equations here, and I have AB and AB, the blue one and the green one. I need to eliminate another variable. And when I'm looking through, we could easily divide by 2, right? Make this in here a little smaller. So if I divide this guy by 2 here, we get divide everybody, and that's legal. So 0 divided by 2 is 0, equals 4a plus b. Well, now it's pretty easy to eliminate here. I just got to multiply one of these by a negative. So let's multiply, let's just do the top one for fun, by a -1 and add it to this one. So now I've got 3 equals -3a minus b. Remember to distribute him all the way through. Okay, add those up, and we get 3 equals a. I have my very first one. So now that I got 3 equals a, I need to plug it in and find b. And it doesn't matter which one of these 2 we use. I'm probably going to use this blue one. So let's do -3 equals 3. Now your a is also 3. There's a lot of 3 here, huh? Plus b. So now we have -3 equals 9 plus b. Subtract the 9. So b is equal to a -12. All right, I've got a and b. So now I got to find my c. So let's change colors here. So to find the c, we have to go up to the beginning, and I'm going to use my a plus b plus c equals 4 again because it just doesn't get a whole lot easier than that. So now we're going to do 4 is equal to, we know a is 3, b is -12 plus c. So 4 equals -9 plus c. So c is equal to 13. Okay, we have a, b, and c is what we have. We know our equation is y equals ax squared plus bx plus c. So I'm now going to take the a, the b, and the c out and replace them with their values. So y is equal to, remember a was 3, so it's 3x squared plus b is -12, so minus 12x plus C is 13, which is the equation that's down here in the corner. All right, it's your turn. Pause and do yours. All right, I hope you did a good job. Let me get back up to where I started. Okay, I took the 146, so this is your x and this is your y, so you got 46. 1 squared is 1 plus b plus c. Now you add the 2, so 84, 2 squared is 4, and 2b. And then you took 114, 3 squared is 9, and 3. I took the first two, and I eliminated c. I multiplied the top one by a -1, and I got this equation. Then I chose the next two, the bottom two, also eliminating c. I multiplied the 84 one by a -1, and I got this equation. My b's were the same, but not opposite. So I chose to multiply the 30 equation by a -1. Added those two up and divided by -4. I got a equals -4. Remember, you could do this in a different order as long as your a was -4. I plugged -4. I chose the red equation. I plugged in -4, added my 20, and my b was 50. Okay, now I chose the a plus b plus c equation, which was 46. Now I got 46 equals 46 plus c. Looks very odd, but totally okay. C equals 0. Now remember, you're using the y equals ax squared plus bx plus c, plugging in the a, the b, and the c, which is -4x squared plus 50x. You do not need the plus 0. I put it on there just so you understand where it would go. So this here, right here, is the final true answer. Okay, good luck on your homework, and I hope you do a great job. Remember to post your questions.